We Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And ooh, I skipped ahead. We are going to be solving or finding roots of complex numbers, as the bumper music is the classic Louie Louie by the Kingsmen. Let's get to it, shall we? Okay, back to that page. Sorry for the mess up there. I guess it's a bit of a spoiler. So, we're going to be solving equations of the type z to the n equals c, where n is a positive integer and c is a complex number. There are going to be n solutions. So, some things we need to know. There are exactly n nth roots of c. If c is an element of the real number, the complex roots must occur in conjugate pairs. And if they're not an element of the real numbers, they do not all occur in conjugate pairs. The roots of z to the n will all have the same modulus, which is c to the 1 over n, and then it would only make sense that on an Argand diagram, the roots would lie in a circle with the radius of mod c to the 1 over n. Okay, and those roots will be equally spaced around the circle. And if you join those points around that are on the circle, you will get an a regular polygon. Okay. So the fourth roots of 2i are the four solutions of z to the fourth equals 2i. Okay, so that's just some lingo. All right, so let's get to it. The roots of a complex number may be found by factorization, but this is usually very difficult. Not so much here, but it usually is. It is therefore desirable to have an alternative method such as the Nth Roots Method. And that is shown, or we'll show you here in this example. All right, so find the fourth roots of 1 by a factorization. So here we go. So what they're asking us to do is to find the solutions to z to the fourth is equal to 1. Okay, well, by factorization, if I move 1 over, I get this, z to the fourth minus 1 equals 0, easy peasy, which is equivalent to z squared plus 1 times z squared minus 1 equal to 0. And then solving for those, let's see, I get z plus I, or further factoring, sorry, z minus I, and then of course z plus 1 and z minus 1. No big whoop. And so then equal to 0, sorry. So then clearly we get z equals plus or minus I, or plus or minus 1. No big whoop. Okay. But let us investigate the nth root method when life will be a bit more difficult than this one. So for z to the fourth equal to 1, let's consider the complex number 0 or z equal to, oh no, I shouldn't say z. Let's think of 1 as 1 plus 0i. Sorry about that. And what does that look on an Argand diagram? I never know whether to say Argand or Argand. I need to look that up. What a loser I am. So imaginary and real. What is that going to look like? Well, it's just going to look like this out to the number 1. Okay, and why is that important? Well, if z to the fourth equals 1, then I can rewrite it like this. 1 cis of 0 plus k2 pi. And it's understood in these type of situations that k is an integer. Okay? Now, hopefully you understand this. Cosine of 0 is 1, blah, right there. And of course, sine of 0 is 0. So this would be, if I solve for z here, Z would be equivalent to cis of K2 pi, and I better put brackets around this whole thing as not to confuse, to the 1/4 power, taking the 4th root of both sides. Okay, and then by de Moivre, and this, sometimes this is a little confusing. This right here is actually the same as r cis theta to the n, is it not? So sometimes I just write that out when I'm using de Moivre. So I remember that, I don't know, it's just a little clearer to me to go from here to here than from this form to here. Okay? Because I'm going to use de Moivre here and rewrite this as z equals cis, you ready for this? K2 pi over 4 by de Moivre. How did that happen? Well, r is equal to 1, and 1 to the 1/4 power is 1. That's right here. And then cis n theta. So I just took 1/4 times theta here. And of course we can simplify that to z equals cis times k pi over 2. Not times, cis of k pi over 2. Sorry about that. And now if we let me do this so we don't get confused here. If we let k equals 0, 1, 2, or 3, and we could use any 4 consecutive integers to find these roots, by the way, then we get z is equal to cis 0, right? Replacing k with 0, replacing k 1 with 1, we get cis pi over 2, cis pi, and cis 3 pi over 2. And if you evaluate those, remember, cis is cosine I sine, so cosine 0 plus I sine 0, cosine pi over 2 plus I sine pi over 2, and so on. Guess what you get? You get z is equal to 1, I, -1, and -I. Isn't that beautiful? Wonderful stuff. Wonderful stuff. Okay, let's try another. Find the 4th roots of -4 in the form a plus bi. So let's do that. Okay. So the 4th roots of z to the -4 are the solutions of z to the 4th equals -4. Say yes? Good. And again, it always helps, I think, to draw an Argand diagram real quick. Okay. And what are we thinking about here? -4, -4 plus 0i, written as a complex number. So real, imaginary. Well, where is that going to be? Where is, what's that going to look like on the diagram? Well, it just goes out to 4, yes? And so if that's the case, then the argument, the angle, is equal to pi. Yes? And if you can see that in your head, then of course you'll be a lot quicker at this. Okay? So now what do we do? Well, that means, maybe, I don't know, it's a little bit easier to rewrite this in polar form. So z to the 4th would be equal to 4 cis pi plus 2k pi. Of course, k an element of the integers. Sorry, I shouldn't say integers for those whose first language isn't English. Sorry about that. Okay. So hopefully you didn't get wigged out by the negative, because you realize that cosine pi is equal to -1 times 4 gives me the -4. And of course, sine of pi is 0. And plus 2k pi takes care of all possible solutions as it did in the previous one. Okay, so very similar. We're just going to say, now we're going to take the 4th root of both sides. So 4 cis, oops, sorry about that, of pi plus 2k pi to the 1/4 power. And then we're going to use the mov again and cis theta to the n. And again, we're just going to this format right here. So that means we're going to raise 4 to the 1/2 power, and we're going to multiply the argument by 1/4. Well, so then z will equal 4 to the 1/4 cis of pi plus 2k pi over 4. Ooh, ooh. And then I'm going to write that. Let's see. What do I want to do there? Oh, yeah, okay. So 4 to the 1/4 is equivalent to 2 to the 1/2, is it not? Or square root 2. So I'm running out of room, so I'm going to rewrite that as square root 2. And so that would be cis pi over 4, right? Why did I say that? Sorry, cis pi plus 2k pi over 4. Nice, huh? Okay, so what in the world does that mean? Well, we would then be able to hopefully see, well, no, not hopefully see, we're going to now let k, we're looking for 4 roots, so k is going to be equal to 0, 1, 2, 3, or 4. So therefore, z would be equal to root 2 cis. When k equals 0, it would just be pi over 4. It would also be equal to root 2, 3 pi over 4. Or cis 3 pi over 4, sorry. And then I'm going to move down here because I want to save some space here. Root 2, 5 pi over 4. Cis 5 pi over 4. I keep doing that. And then root 2, cis 7 pi over 4. I remembered that time. Okay. And so then you need to know your cosine and your sine. Your pi's over 4 are some combination of plus or minus root 2 over 2 for both cosine and sine. So that would mean that we would get the following. We would get z equal to root 2 times root 2 over 2. This is for pi over 4, plus root 2 over 2i. For 3 pi over 4, we would get z could also equal root 2 times negative root 2 over 2 plus root 2 over 2i. If you are not understanding this, then sketch the unit circle and don't tell me you're not understanding it, because you should know your unit circle. So negative root 2, this is for 5 pi over 4 over there in the fourth quadrant. So that's going to be both negative for cosine and sine. And then for 7 pi over 4, cosine is positive, so that's root 2 over 2. And sine is negative, minus root 2 over 2i. Yes? Yes, yes, yes? Okay. So what does that mean? Okay. That means for this one, that implies that z is equal to 1 plus I. Yes? Just multiplying through. Okay? And z is equal to negative 1 plus I, simplifying. Z is equal to negative 1 minus I. And then z is equal to 1 minus I. Okay? All right, so we're going to go ahead and stop that, and we will continue with part 2 of this. We will go out with some more Loué, and we will be back soon.
Yeah, 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 yeah.